Hi students, in the previous video we have seen how we can prepare ammonia by general methods and also in the laboratory. Today we have some alternate methods. In this video we are going to see some alternate methods for the preparation of ammonia. So keep watching. Alternate methods for the preparation of ammonia. As we have seen the previous method, alkalis react with ammonium salts. Here we have metal nitrides. Metal nitrides reacting with water. Okay. So how do we get metal nitrides? But metals, when burning in nitrogen, they give metal nitrides. Example, magnesium burns in nitrogen, magnesium Mg plus N2. On burning, it produces magnesium nitride, Mg3N2 is magnesium nitride, so 3 Mg, right? Calcium also forms calcium nitride. Calcium reacts with nitrogen. When burnt, it will produce Ca3N2, calcium nitride, so 3Ca. Aluminium reacts with nitrogen. Aluminium is a trivalent metal. It also burns in nitrogen, giving aluminium nitride. So aluminium nitride. Okay, so metal nitrides react with metal nitrides plus water. Water may be cold or warm. Yes, so you get metal hydroxide. Metal hydroxide and ammonia. So this is the general method that we are going to see. So let us take some metal nitrides one by one. The metal nitrides we have seen. Magnesium nitride Mg3N2, yes, reacts with warm water. So you get MgOH whole twice, magnesium hydroxide and ammonia. So 3 MgOH whole twice and 2 NH3. Okay, 6 H2O, it is balanced, right? Same way, calcium nitride, Ca3N2 plus H2O will give CaOH whole twice, calcium hydroxide and ammonia, 2 NH3, 3. So 6 and 6 hydrogen, 12 hydrogen, so 6 H2O, 6 oxygens, right? Now we'll take aluminium nitride, Aln plus H2O. Here we get aluminium hydroxide, AlOH whole thrice and NH3. Okay, so 3 H2O, it is done. Okay, so aluminium hydroxide and ammonia, right? So these are the reactions. Now the apparatus, we consists of round bottom flask fitted with a thistle funnel and a delivery tube. We have the apparatus here. Here you have the round bottom flask. Magnesium nitride is taken. There is a thistle funnel here placed there. Warm water is poured through it and the reaction takes place, and the metal hydroxide will stay in the solution, whereas ammonia gas moves out. It will come, and as we have seen in the previous method, again a drying agent, drying tower is there, where quicklime is kept there, drying agent, which is quicklime, calcium oxide, commonly known as quicklime, and it is dried. So dry ammonia moves into the gas jar, right? So the metal nitrides are placed in the round bottom flask and warm water is poured through the thistle funnel. So as we have seen. Secondly, the lower end of the thistle funnel, the lower end is kept dipped in the warm water in the flask. It should not be above, otherwise the gas can escape through that. To prevent that, we have the liquid pouring in and it is controlled and it is dipped in, right? So these are the arrangements that we have. Now what happens? We get ammonia gas coming out and the ammonia gas is passed through the drying agent. Now by the way, metal nitrides are expensive because producing metal nitride by burning in nitrogen is a difficult process. It is expensive, so this method is used rarely. Okay, now drying agent for ammonia, quicklime is basic drying agent. It is suitable drying agent, it is suitable for ammonia. Okay, now phosphorus pentoxide is not suitable, cannot be used because it will reacts with ammonia, so we cannot use it. Fused calcium chloride cannot be used, it also reacts with ammonia, right? And concentrated sulfuric acid, it's an acid, reacts with alkali, ammonia reacts so cannot be used. So the only drying agent suitable is quicklime, that is calcium oxide, which is basic and does not react with ammonia. It will dry, absorb the moisture. Now by collecting the gas, we have the downward displacement of air that we have seen in the apparatus. We can see the gas jar is kept upside down. You can see here the gas jar is kept upside down. So the air inside move outside like this. So downward displacement of air, and ammonia moves up. Okay, that is downward displacement of air. Now ammonia is lighter than air. I have explained it in the previous video also. 8.5 is the density of ammonia and air has a density of 14.4. It is lighter than air, so it will push the air downwards and it will come downwards. Okay, so it will push the air up. Our ammonia moves up and air is pushed down. So lighter gas will be up and heavier gas will move down. That is the concept here. Air being heavier moves down and ammonia lighter moves up. Ammonia is highly soluble in water. It will dissolve in water. If it is passed through water, it will dissolve, giving ammonium hydroxide, NH4OH, which is an alkali. So you cannot collect ammonia if you pass through water. So it cannot be collected over water. Okay, ammonia cannot be collected over water. Please note that point, cannot be collected over water. Okay, now the next thing is how to test the ammonia gas produced. You can have a glass rod dipped in concentrated hydrochloric acid dipped into ammonia. You have a gas jar having ammonia. Now usually it is kept upside down. Why kept upside down? So that ammonia does not escape. Being heavy, lighter, it will stay up. Ammonia is inside this. You have a glass rod dipped in concentrated hydrochloric acid. Bring a glass rod dipped in concentrated hydrochloric acid into the jar. What will happen is you will get dense white fumes. Dense white fumes of ammonia will be formed. Dense white fumes. What are the dense white fumes? Ammonia gas reacting with the corn HCl will produce NH4Cl. Ammonium chloride is produced, which is the dense white fume. This is the dense white fumes. So you have understood how we can prepare ammonia from metal nitrites and how we can collect, what is the setup of the apparatus, and also how we can test the gas. So students, I hope you understood how the alternate method can be used, that is from metal nitrites, how we can get ammonia, how we can collect it and dry it and also test the gas. So thank you for watching. You can write your questions in the comments and also like and subscribe. Thank you.